will kick us off because we have a great group of speakers today. Welcome. This is the last in our Impact 2021 series that we put together. And what I want to start with is by saying I'm pinch hitting for Rochelle Ain and Julie Janiski. They are the co-chairs of the Carbon Leadership Forum Boston community. The contact information here is a great way to reach them if you are interested in engaging in the community. There are meetings every other month, and we have all sorts of communities within the Carbon Leadership Forum that are focused on different aspects of the issue.
Lisa, I can jump in if you like.
Oh, you're here. Yes, go ahead.
Hi. Sorry about that. We had a little bit of last minute reorganizing. So definitely, yes, thanks everyone. And a special thanks to Lisa Carey Moore for all of the work, amazing work she's done for this entire series. Today is the last one in a set of 7. The working groups within the CLF Boston Hub are on the left-hand side of the screen. The education series group is the one that's put on the event that we've had throughout the month of June. And the resources and tools is a work of effort amongst the entire group, and we're working on getting that posted on the website so that everybody has easy access to all of the good types of tools and other resources that are out there. The education series group started in 2019 with the call to action and a one-day event, which was really incredible. That was followed up last year with an Embodied Carbon 101 series and 12 sessions. Those are all available online to watch free of charge. So if you're interested, please do check them out. Same will go for the series that we've been holding this month around impact and implementation, 7 forum-based sessions specifically around building sectors and typologies. Today on Home Sweet Home for small scale residential, and some fantastic instigators and speakers. And we'll follow up with something to be determined and coming out of all of the conversations this month. So on the next slide, just a recap. Next slide
is not in great shape. It's the old one, and I'm sorry about that, but yes.
No, that's fine.
Recap.
Yeah, okay. So the takeaway is that we've had some really incredible events over the course of June. And today is the last one in that series. Architectural review webinar is not CLF Hub sponsored, but is an event that is posted on all of our LinkedIn sessions and other things that have been communicating what this is about. The CLF Boston Hub, as Lisa noted, meets every other month. It's a BSA knowledge community in addition to being associated with the Carbon Leadership Forum. Our June session we pushed to July because we had all of these sessions instead. So July 15 is the next session, and then that's followed by August, October, and December. I think in closing, I would just say thanks again to the speakers. Thanks again to Lisa. Thanks to all of you for being here. And please do email us at clf.boston@gmail.com if you'd like to be added to the mailing list, and from which we always send a reminder out around upcoming meetings. I'll post that in the chat as well. Thanks, Lisa.
Thank you. I just posted that.
Thank you so much, Lisa and Julie, and thank you everybody for being here. I am Rachel White, the CEO of Big Meister Design Build, a residential remodeling firm for almost 40 years old, based in Newton, Massachusetts. And I am thrilled to be participating in this forum and to be joined by a terrific, really tremendous group of practitioners to engage with you all, learn with you all about strategies for reducing embodied carbon in single family and small multifamily buildings. I will briefly introduce, just very briefly, the folks who will be in conversation with today. The first is Lillian Marr. She is the co-founder of Building Logic in the Hudson Valley of New York. Matt Coffey, architect with South Mountain Company on Martha's Vineyard. Chris Magwood, director of the Endeavour Center, a sustainable building school in Peterborough, Ontario. and Jacob Recusen, who's the studio director and building science director at New Frameworks in Vermont. Now, before we get into it, I'm going to give you all a quick rundown of what we have in store for you. We're going to start with each of us is going to give a very short presentation, 4 to 5 minutes. And then we're going to start off with Chris, who's going to start with sort of a big picture overview of why we need to focus on small scale residential buildings and where we should be focusing our efforts. And then the 4 of the rest of us are going to just walk you through one or perhaps a couple of ways that each of our individual practices is changing, has changed in response to our efforts to address embodied carbon. We're going to move from there to a facilitated conversation. We have a couple of lead-off questions that we've given some thought to present for each of the 5 of us to address, but we really are very much hoping that the conversation in the second half of the session will be focused almost entirely on your questions, your concerns. So Jacob and I together will be closely monitoring the chat and bringing questions forward for all of us to address and discuss together. So please liberally use the chat, whether it's for individual practitioners or for the entire group to discuss. And so without further ado, I will turn it over to Chris, who will be giving our short intro presentation.
Great, thanks. I really like, we were called speakers or instigators, and I would love to categorize myself as the latter. Happy to be here instigating with all of you, and thanks to everybody who put this together and who showed up today. And I hope it's valuable for everybody. So I'm going to do a little bit of framing here, and starting with why we would be talking about low-rise, and in this case, sort of low-rise residential construction in particular. And it's because that, well, there's a few reasons. A, it's a lot of what gets built in North America is by sort of floor area and sort of dollar value, about half, if you look across Canada and the United States, of what gets built would fit in this category. And another big reason is that we are less reliant on structural concrete and steel in the way that people making larger buildings are. And those 2 materials alone tend to account for an awful lot of the embodied carbon in buildings. And when the industry gets together and talks about this, it's usually large firms that use mostly concrete and steel. And so that tends to be the lens. Whereas in the low-rise sector, we have a lot more material options. We have a lot more competition between different sort of types of materials and types of assemblies. And we have a lot more carbon storing options within those. And in a lot of ways, less barriers to innovation because the performance thresholds for smaller buildings are sort of easier to meet in various ways than large buildings. And obviously, there's a lot of us, me, you, people who are practitioners in the space working on all of this. So really quickly, I did a study. I sent myself back to school in 2016 to do a master's to kind of figure this out for us at Endeavor, what the carbon footprint of our buildings might look like when we looked at the materials. And out of that study, I sort of arrived at the fact that you could build the exact same building with the exact same performance characteristics, but it could have an incredibly wide range of potential carbon footprints depending on the materials you chose. So from 240 plus kilograms of emissions per square meter of floor area on down to potentially storing over 130. So, you know, pointing out the fact that what we actually choose for our materials really matters when we're building at this scale. In the last 6 months or so, we've started working on a really large scale benchmarking study for the Toronto region, where we're looking at 100 plus new homes that have been built in the last 2 years to do some real world modeling of what's been built there. And we're also just at the end of a study for the Canadian government for Natural Resources Canada, where we looked at a range of different residential archetypes across the country at different levels of the energy efficiency code that we have up here. And I'll present just a couple of those results. So when we are modeling the buildings that NRCan uses as its archetypes across the country, we actually found that the worst case scenario was worse than what I painted in my thesis. We got results in the sort of up to 700 kilograms of emissions per square meter, but the average across all of the sort of bad material archetypes was just over 500, so double the carbon footprint that I had predicted in my study. We did find that we could use a sort of moderate materials, we called them palette, and end up at, that should say kilograms, not tons, 142 kilograms per square meter. We also found that if we picked the best materials from what was available conventionally and code compliant today, we could get that down to 2, so a huge reduction. And that if we selected the best possible materials, we would be carbon storing to the sort of tune of 50 kilograms of emissions per square meter. So just to give you a sense of what that looks like, if we look across Canada, and I think you could probably safely multiply these numbers by 10 and get a good estimate for the United States. But if all homes in Canada were built with our high carbon model, we'd be talking over 26 million tons of emissions per year from the materials from new homes. If everything was built with the sort of mid-range materials that we specified, that could be as low as 7. And we kind of did an average landing somewhere in between those two, which seems sort of likely for an average home that's still 16 million tons, or probably in the American context, 160 million tons of emissions coming from the materials. And if we used our best possible materials, averaged it across all of the samples we did, it would pretty much be zero carbon. That we show a little bit of storage here, but essentially we could get that carbon footprint from the materials down to pretty close to nothing. And just sort of quickly looking at one example, their bungalow model in Toronto, looking at the sort of operational efficiency as it moves up tiers in our energy code, and also looking at the different sort of material tiers that we set up. And what we see here is that if we use the worst materials, they're the equivalent of 273 years of operational emissions. So, an area like Toronto with an electrified building on a relatively clean grid, the material emissions are kind of the bulk of the emissions. And even the mid-range materials, those materials represent 80 years of operational emissions. And so just sort of highlighting the fact that this is a place to put a fair bit of our attention once we have buildings using cleaner energy sources. So if we look at the savings as we move up the energy code tiers over 30 years, if we bump a house up from tier 3 to tier 5, which is the highest, we're going to get 5.7 tons of operational savings over 30 years. If we jump down from the high carbon materials to the mid-range carbon materials, we're going to save 106 tons of emissions. So there's basically 550 years of those operational savings we would make up just by changing the materials down from high carbon to mid-range carbon. And I'll just wind up by saying that we worked with a small municipality here in Ontario to start the first incentive program, where they worked with us to set a threshold of 75 kilograms of emissions per square meter in order to get your permit fees refunded. And right now we're working on similar programs for the cities of Nelson, Castlegar, Vancouver, and Toronto. So if this is of interest to you, I would be glad to talk to you about how your local city or municipal government could be considering this too. And just a very quick look at one small building that we did here. in Canada for Trent University, where we modeled the building that they were going to build. They were looking to build a building that had about 211 tons of emissions associated with it. And we worked with them on choosing different sets of materials and got that building down to just under 6 tons. So over 200 tons of savings at a no cost difference to the university, but a huge impact on the climate. And I think, that's the kind of impact that we can have in this low-rise sector, where our options for the structural, the insulation, and the cladding materials are so open to innovation and new approaches. And with that, I will stop sharing and pass it on.
Thank you, Chris. I think, Matt, you are up next.
Okay, can you see my screen there?
Yes, we can.
Hi, Matt Coffey. I'm an architect at South Mountain Company. We're an integrated architecture, engineering, construction, and solar company focused on Martha's Vineyard. This is a recently completed project on a sensitive coastal site where we've made our best effort yet to reduce carbon in our buildings. We built a custom home for the family 20 years ago that really embodied the range of what South Mountain was doing at the time. Highly crafted, well insulated, featured a host of different reclaimed woods, and was really well sited into the landscape. A second building on the property was a seasonal structure with 2 bedrooms and a little kitchenette. We did a deep energy retrofit to about 1,000 square feet of that building and added a 700 square foot addition to accommodate year-round living. The clients were particularly interested in responsibly sourced materials and pursuing carbon reduction. So to that end, we looked into wood fiber insulation as our approach and alternative to our typical rigid foam, SIPs, nail base building wraps. In terms of the building assemblies, we did, starting at the bottom, we did a slabless crawl space to eliminate some concrete. We did wood fiber bats at the rim joist. On the exterior walls, clear pine clapboards, wood fiber wrap over dense packed cellulose walls with a total R value of about 40, triple glazed wood clad windows. On the roof above the ceiling plane, we did a 2x6 subframe that we infilled with rock wool bats and covered all of that with a wood fiber board insulation. Got about an R45 roof. Just wrapped up the project about a week and a half ago. So we did a carbon analysis that started with a baseline building, an affordable housing home, single family home that we had done years ago with more conventional means using a combination of foam and cellulose. And that resulted in about 400 kilograms per square meter. When we did an analysis on this building, we focused just on the 700 square foot addition. This is something our mechanical engineer, Mark Rosenbaum, put together. And we ended up in the range of about 200 kilograms per square meter. The embodied carbon was about 200 kilograms before the impact of the carbon storage was considered. And if you see on the right, the yellow bar, about a quarter of that was accounted for just in the wood fiber board insulation. But the wood fiber stores double the carbon that is emitted during its production. So had all of the wood products that we used in this building been sourced from a sustainable managed forests, such as FSC certified, we could have gotten the focus study. This 700 square foot addition could have been a carbon storing building. A true whole building analysis of this building, including all the finishes, the metals, mechanical and electrical equipment, solar array, etc. We think we're at about 130 kilograms per square meter. or about a third of our typical baseline home. So we had various existing assemblies and geometries to solve for. It made it a tricky place to do a deep energy retrofit to. Our field crews liked working with the wood fiber board. Once they worked out strategies for pinning it in place and cutting it, it's a thick material. They liked that it had a very robust tongue and groove profile at the edges. Admittedly, our roof, built up roof assembly was pretty labor intensive. It also left materials pretty vulnerable and really relied on having a good weather window. We had considered alternatives such as doing 2 layers of the wood fiber board to get that same R45 roof, but we didn't feel comfortable running 14-inch long screws down into the structure. So if we were to do this again, we would likely look at doing it as some kind of a panelized assembly we could do in more controlled conditions and then lift sections into place. Also just learned that wood fiber board it's more expensive than using foam. It was about, for a 1 foot square to get a value of R1, it was about 4 times as expensive as using polyiso. But as we know, price is not the only driver. We have to consider worker health, site contamination, production and waste streams, et cetera. And here on this project, we felt more comfortable having sawdust, albeit with some binder in it, in a sensitive coastal site where they had chickens and dogs free ranging throughout the course of construction. So we feel like wood fiber is one more tool in our kit. And now we're looking at how to solve for below grade. So on 2 upcoming projects, we're looking to use Nexem, formerly Durasol, these ICFs from Canada. This is an alternative to our standard 8-inch concrete walls with 3 inches of polyiso. And these blocks are made from mineralized wood mixed with cement and result in about a 40% reduction in concrete from our standard assembly. Uses mineral wool inserts. And for the R21 blocks that they have, and when you account for the carbon storage of the wood that's in the material, it's about 4.5 times less carbon than our standard assembly. Also using slabless floors on grade, trying to eliminate concrete, 2 layers of subfloor sheathing with staggered joints instead of using a 4-inch slab. That's about half the embodied carbon. We're also very interested in learning more about using foam glass, glavel, and that would get rid of the last major place in our buildings that we're currently relying on foam. Our objective is really to create buildings that are storing more carbon than is emitted in their creation. And these are all steps along that way. In 2017, at a NESI session that New Frameworks put together, I got one little tidbit that stuck with me. I learned that wood products can require less than 2% of the energy required to produce something comparable in concrete or steel. Even if that's 10% or 20%, it's still pretty shocking. And that combined with all of the wonderful characteristics of wood and working with wood, its natural beauty, its ability to take on character, its strength and thermal qualities, and very importantly, its carbon storage potential. It's a real call to action for all of us to thoroughly consider where wood products can make our work better. That's it.
Thanks, Matt.
Yeah, thank you.
Before I turn it over to Lillian, I just really want to encourage people again to please can post questions in the chat as we go along for Jacob and I to bring forward once we get to the Q&A and discussion. Lillian, I'll turn it over to you.
Thanks, Well, I'm a builder based in the Lower Hudson Valley of New York, and we also are working with Gutex right now on a deep energy retrofit. And I'm just going to show a few slides as sort of background. Just this is what we're doing right now, and what I really want to focus on is some of the process that I encountered on this project that has really helped me become more assertive, I think, in steering projects to being just more embodied carbon aware and realizing that I can have more impact on projects than I think I realized in the past. We typically have clients who come to us who've already engaged an architect, and I prefer if we can be involved early on and be a part of the design development in terms of making suggestions either about materials or just framing. And in this case, we were given a fully resolved set of plans that came from a firm that it does a lot of passive house certified projects. And it was a tough one for me to really, I think as a builder, often we're like, we're here to serve you. We will execute your plans, you know, giving the client what they want. And we love working with architects, but this was tough. It was originally designed with 6 inches of exterior rock wool, which priced out just, I think it was, I don't know, $40,000 in materials or something. It was really crazy. And this home had an oil-fired boiler that they wanted to replace with a propane-fired unit. And I found that I could advocate for some changes that I think overall really came to just significant changes. And one of them was the Gutex. Gutex is pricey, but this is a little lower R value than the original rock wool that was spec'd would have given them, but it's 4 3/4 inches of Gutex, and it's giving a really comparable overall result. And I think what I've learned also from Chris and Jacob and Ace in previous just their presentations is it's no longer, you know, my focus originally had been lower the operational energy of a building, you know, use more insulation, use better windows. And now I'm just, you know, that's all turned upside down for me. And it was not a hard sell to make this change. And we ended up also engaging a mechanical engineer to do a little modeling and show that indeed heat pumps were going to be a great solution for this home. For some reason, the architect had heard and believed that heat pumps don't actually work unless the home is certified and really just super insulated. And I think that was just a good reminder that we all have our assumptions and beliefs based on, you know, our practice to date, and we have to just challenge ourselves all the time on what we believe is possible or works or is the best idea, because a lot of times it's not what you think it is. And so yeah, these are just some details of the install. I like to install Gutex with the battens, the rain screen battens going up, but this is going to be a reverse board and batten. So we use some just tacking it up in a few places using some metal washers to hold it in place. This is a detail just where it's over rock wool that we did use over the foundation and some cement board protecting it. And the other sort of real major challenge on this project was there are a lot of tricky details that were not detailed out on the plans, and it's hard to remember all those spots where things just aren't how you normally do them. And just funny transitions over different materials, require more time and planning, but are not necessarily that hard to execute once you have a good plan. I think that what I'd like to leave everyone with is just that I encourage everyone to draw a line in the sand about something that they're just not going to do anymore. And also, well, for us, it's not use foam above grade. We still, in many cases, don't have a solution for maybe wet basements, but we don't use it above grade now. And I think that saying that to clients, they appreciate it if they hear that we don't do something, but we also do. You know, it's not always negative, it's positive, and they appreciate that we've made a decision. They respect our opinions and they value our experience. So if you're a designer and you're a little hesitant to introduce some new wall assembly or something, it's you can say this is how we do things now. Yeah, we don't use that material anymore, or you know, this is our wall assembly. We do double stud and cellulose, and you know, I think people are like, oh, okay, you know, I trust you. And maybe you scale back the overall footprint and the glazing, and it's not gonna really hurt your budget. So those are my little takeaways from this current project.
Thank you, Lillian. One quick question before we move on from you to Jacob. There was a question from Andy about the savings. Did you realize some savings in equipment costs that might have offset the additional cost of insulation, or was that not the case?
Yes. Once we initially, when the designer moved from, you know, the existing hot water baseboard system to mini splits, they put a mini split. I think there were like 10 mini splits in this house, and you know, a little bit of money towards a mechanical engineer meant there's 2 air handlers. It's much scaled back.
Yeah. And
also, I'd say labor is often what's more expensive. So the rock wool solution, not only was it the material more expensive, but the labor in installing 2 layers of rock wool on the entire exterior of a house, as opposed to 1 layer of Gutex. There's a lot of labor savings there too. So
thanks, Lillian. All right, Jacob, you are up.
All right, I'm gonna talk about how to dial down the carbon input of concrete in residential projects. So much information. I overpacked these slides for future reference. I'm gonna go through them really quickly because I would rather have a longer discussion, but feel free to reference more of this information in the future. So I broke this into a few different categories of where we can make design detailing decisions, or sort of different categories of where we can make decisions that will reduce the emissions impact of concrete along the entire trajectory of a project. This is looking at a project, a residential construction job that we did. Actually, it's still under construction in the finishing phases. This was all poured last year. So we start with design. Obviously, if we can reduce the amount of concrete that's needed through massing and the size and shape of the building, that's the best cost-effective way of getting concrete out of the building, by just needing less concrete. We also chose, in this case, a foundation approach, a shallow frost protected foundation. In this case, it was a shallow frost wall with an independent slab. That was a good way for us to also reduce the amount of concrete, because a full basement was neither required nor desired for this project. And then there's other approaches in terms of choosing ICFs, wood foundations. Matt mentioned the slabless slab. So a bunch of those are all different sort of design level decisions to be able to get concrete out of the project. Then looking at engineering, I find that there is not nearly enough structural engineering brought to bear in residential projects, largely because soft costs tend to be quite squeezed, and a lot of folks will just do really safe numbers to avoid having custom engineering, and that results in over-engineered projects that have way more Portland than is necessary and way more concrete and massing than may be necessary. So from investing in a little bit of custom engineering can reduce wall sizes and slab sizes and save a whole bunch of material without affecting performance whatsoever, as well as being able to dial down strength ratings for different parts of the pour or different parts of the assembly. And then also looking at, we'll talk about this in a second, we look at different additives and formulations of concrete, that'll affect the cure time. And so having engineering that acknowledges 28-day or versus 56-day cure times for getting to appropriate strength ratios will allow for wider flexibility in mix design. And that also relates to project management. So that's where the GC or CM or whoever is project manager is responsible for the scheduling of knowing that there may be some impacts. And we'll talk about that at the end, looking at lessons learned. So material specification, this is what everyone likes to talk about because it's more tangible to the material concrete itself. I want to give a lot of credit to Russ Miller Johnson with Engineering Ventures, who is an engineer that we work with a lot and from whom we have learned a lot about improving our specifications. Using gap graded aggregate and getting your aggregate specifications to reduce the total amount of paste is one way of, again, just getting Portland out of the mix writ large. And using recycled concrete aggregate is another way of reducing your aggregate impact if that recycled concrete aggregate is coming from a local source and you're not actually creating more embodied emissions from the manufacturing and transport of that relative to local stone. So that's going to be a site-specific and resource-specific approach. Everyone, let's talk about fly ash and the supplementary cementitious materials, SCMs. That's a lot of folks go to because it's a direct, in some cases, in some mixes can be a direct replacement for Portland to get to very similar performance values. In this project, we went really big. We went to, I think, a 40% replacement of Portland using primarily blast slag, as well as the aggregate specification. And that was really successful, but definitely had some impacts in mix quality. And we'll talk about that in a minute. So numbers like 25% or so will be more negligible once you get above 30%. There can be more real direct impacts in the mix, and not all SCMs are the same. So there will be different properties impacting your mix based on the SCM you're using. There's also a lot of steel in concrete for reinforcement. And so attending to the specification of the steel is also super important. High recycled content is pretty much the best that we can commonly do, although they're all basalt and non-ferrous reinforcement bars that I personally have not worked with, but I know that they're out there and tend to have a lower emission profile than their virgin steel counterparts. And then there's more products out there like Carbon Cure, which is injecting carbon dioxide into the mix as a Portland reduction mechanism, and also to be able to entrain that CO2 permanently. And then non-potable water as a spec, which is something I love seeing. Russ turned me on to that one. And when you consider the additional emissions from filtration and pumping and sort of potable water management, that can be another way of getting some emissions out of the mix, so to speak. Process is also really important. That's the last sort of bucket of potential improvement locations there. Getting really clear goals. Boy, am I a stickler around getting goals with clear metrics that can be translated into specifications is a really important place to start. And not all specifications are the same. So if you're working with a concrete spec that declares pounds of cement in the mix, that's gonna be pretty restrictive. Reduction against baseline is better, but you can name a really high baseline and kind of game that system. Whereas putting some max emissions or max strength ratings to keep the Portland manageable is another approach. And then transparency, asking for EPDs or mixed recipes that can allow you to produce a digital EPD is fantastic in terms of documenting and proving out the actual impact of the material. And then there's a whole lot of coordination that's involved in this material in particular, from the ready mix plant to the subcontractor to the contractor. So all of that needs to get managed. All right, the last thing I'll leave here is a few lessons learned. The cure time is longer. We used an accelerant in this mix, and that definitely helped, but that's a thing to attend to for sure. Workability is interesting when you get especially those higher SCM values. The mix plant said this couldn't be troweled at all. Our contractor was actually able to apply a light trowel to it, but not a full bull float. So depending on the finish quality you're looking for, that would really matter. In this case, we're getting all finished floors on top of the slabs, so that was negligible. That would similarly go with color and so the aesthetics. So I wouldn't have to be careful with the finished slab to do test batches. And then durability was interesting. It actually took quite a long time for this to get strong. There were some cons for nailing in subfloors and using air barrier adhesives onto the concrete at the time in construction sequencing we needed it. And it worked out okay, it was fine, but it was definitely an impact and worth noting, and we would evaluate that for future mixes. I'm going to stop there and look forward to discussing more after the presentations.
Thanks, Jacob. So we're running longer than we had anticipated. So I'm gonna be really quick in my short presentation, and then we'll move directly into questions and discussion. So as I mentioned at the beginning, Bigmeister is a remodeling and retrofit firm. We don't do any new construction, and we strive not to do additions. So what I'm going to focus on here, sharing a little bit about how our, as our understanding of the importance of embodied carbon has grown, how we have been evolving, our approach to insulating attics and roofs has been evolving. And I really liked what Lillian had to say about lines in the sand and not using foam above grade. So you'll see the evolution of how we're insulating attics and roofs. Okay, so this is before we started taking carbon, embodied carbon seriously. This is how we were insulating pretty much any attic or roof we encountered, unless it had was completely open and had no mechanicals and no storage. We were installing 3 inches of closed cell foam on the underside of the roof. We see we were using back in 2017 the high global warming potential foam still. I'm embarrassed to admit, and then filling the rest of the rafter bays with open cell foam. So that was our standard approach until really 2019 was a turning point for us, as I think it was for many people after the Building Energy Conference, when Chris and Jacob and Ace McCarlton gave their keynote on carbon drawdown now. And so our first step towards a smarter, carbon smarter approach for attics, open attics with mechanicals and storage, is what we call a low foam approach, which is, you know, keep in mind, we're not taking the roof off, right? We're an insulating from the outside. This is a relatively new roof. So we're insulating from the inside, but we need to maintain the attic space for mechanicals and storage. And so we're building down the rafters, starting with 3 inches of the low global warming potential foam, and then dense packing the remainder of the built down rafters with cellulose behind a smart vapor membrane. And when we ran the numbers on this approach, the embodied carbon emissions of this approach compared to an all spray foam approach, this came out roughly carbon neutral. And once we're counting the carbon storage potential of the cellulose, compared to roughly 3.5 metric tons of carbon CO2e for the all closed cell, the low global warming potential closed cell foam. Second approach we've been working on for open attics with mechanicals is these head houses. In this case, really a storage room. We'd like to keep them smaller. If we can convince our clients to get rid of all the stuff they store in the attic, then we can build a small head house for the HRV and the or the ERV and the ducted heat pump. You know, the air barrier goes along the attic floor and then up the walls and across the ceiling, the roof, you know, ceiling plane of the head house. And we've done this now on a number of projects, and seems to be a good alternative for open attics that we need for mechanicals as well as for lighter storage needs. We're also now turning to looking to for finished slopes, cathedral ceilings, to dense packing those. One little note that Chris mentioned at the beginning is code compliant methods. This is dense packing cathedral ceilings is not a code compliant method. And so we're finding in some towns that we're needing, you know, a stamped letter. We've been relying on Building Science Corporation for some support in this. But sort of, you know, so retaining the finished slopes, taking out the existing insulation. We're following, I guess, what we consider a more cautious approach here by maintaining a micro attic above So dense packing the slopes and then keeping along the flat of the attic, insulating that flat, and then installing a ridge vent for any moisture that builds up in order to escape. So this is just to give you a sense of the direction that we have been moving in one small area of our practice towards a carbon smarter approach. And now I think we're going to move into the chat. And actually, Jacob, well, if you want to tee up the first question, I'll spotlight the five
Great.
of us so that we'll all appear together.
Super. Well, one question I really wanted to hear folks answer. So are you setting carbon goals for your projects? And if so, what are they? And if not, why not? And I'll just open it up, unmute, jump in there, or I'll call on folks if it's quiet.
Yes. That's, a direct result of sending me back to school to do my master's was to, specifically figure out, can we target, at least a zero carbon footprint building, or ideally carbon storing on everything we do. So that's sort of an express goal for us.
I'll say that because I've just been very reactive to date. It's just like, get it lower where I can, however I can. And I really am starting to do more accounting on the project, and that's helping a lot. And I think as I can share that accounting with colleagues, I'll see more collaboration. But the just the time, number of hours in the day is holding me back a little. But it's a goal. Thank you for keep saying it.
Jacob, are you setting embodied carbon goals for your projects?
It's a great question. We are setting goals around design process and making sure that we're accounting for them. And we've got some like a preferred materials palette that we work off of. And what I'm trying to do right now, we aren't really setting formal metric embodied carbon caps in our buildings right now, because I feel like every time we've done that, we end up coming in way lower. And I realize I don't have a good enough sense of smell of what a really good appropriate goal is for a lot of our projects. And so that's kind of like a growth edge for me, is to have enough of an understanding of the impact of our own projects and what's possible to make sure we set goals that are actually worth setting and worth attending to. But right now our goals have really been around just having carbon accounting be a regular part of our process and making sure that we're looking at numbers, period, is our kind of primary immediate goal.
Yeah, numeracy is a big push. We all need to get much more familiar with, and Chris, we have, you to thank for a lot of the informing us on the numeracy. I have a question. I'm wondering what people feel like is the biggest challenge to be, I'm thinking back to Chris's framing for us, and in a way it seems like, as you mentioned, with the best conventional materials we have available today, we could be building basically carbon neutral buildings. And so why aren't we? Why is the, in your study, the one that you're doing, I think it was for NRCan, your assumption is that it's mostly the homes are going to get built with the worst or the moderate materials. So what are we see as the challenges?
I think a big one is
just the literacy. Oh, sorry, Matt, go ahead.
I was just going to say that the big one is just the fear of the unknown, across the building industry. Is people are pretty scared to take risk and to stray away from something that they've done, something that their trade partners feel comfortable with, something that they can definitely get off the shelf within a 10-mile radius. And so I feel like our firm is in a pretty unique position, being design build, where we get a chance to work through a lot of this stuff with the folks that are actually going to be building it well in advance, and are not just dropping it onto a builder and letting them kind of fend for themselves. So we get a chance to try some of these new things. And I also think, just with something that came up in the chat, this wood fiber plant that is promised to come online in the next year or so, I think that's going to be a game changer. I think Glavel opening up a plant in Vermont in the next year, that's going to be, it's supposed to be coming in at 1/3 of the cost of what it was when it was coming from overseas. And hopefully the wood fiber will be significantly less expensive too. I think those are big changes that are happening. And the more that practitioners like that are willing to take the risk and try new things can show others that it doesn't have to cost a bunch more, and it's pretty viable, and the people that are working with the materials in the field are comfortable with it, then we can hopefully set some example and get more buy-in.
Yeah, it was really interesting, the process that I did with the Duro Dummer municipality, where they kind of brought about 10 designer builder folks from that community to the table to help design that program. And it was really great to be able to kind of have the models and the numbers and those folks in the room where, like, they set that 75 kilograms of emissions per square meter threshold because we went around the room and sort of iterated a building that is, common to what everybody there would sort of be doing, and iterated a building where everybody was like, yeah, I could build that. That's easy. I can get the materials. It's not going to cost me more. And that's where that carbon threshold was. And when I modeled the buildings that people had done there over the last 5 years, it was over 300 kilograms of emissions. So like we sort of won that, 225 kilograms per square meter just by having the conversation and finding, like, that was absolutely the lowest hanging fruit. But it took everybody sitting around the table and kind of, working through, what would these changes look like? What are these materials? No, that's too expensive. No, I can't get that, to sort of find that spot. But when we found that spot, it was a really significant move. And it would be great to see that threshold now go, get pushed lower. But even just to take everybody who was like, 300 plus down to 75, and everybody's like, yep, that's doable. That was, I think that kind of collaboration is really important to sort of move this along.
That's an incredibly hopeful story, Chris.
Mm-hmm.
Lillian, were you going to chime in here as well? You're on mute.
I think that some of the restraints that I'm seeing are a lot of people in our industry who don't attend educational conferences or workshops and just aren't aware of either the materials that are out there, or how to get them. It's a little bit of a mystery. Or I think also even just really understanding what embodied carbon is. I think it's becoming more widely understood, but I feel like I have to act as a teacher a lot, which is fine. I love sharing the knowledge, but I feel like it's lonely out there for myself, and I don't know. We need to, like, more education, I think, is what comes to mind. And also, we all rely on doing what we know how to do and things that have worked for us in the past. And I have architects I work with who, they've used SIPs for a long time, and they've worked, and it's good insulation, and they're just not seeing that next step to something different, and it's hard for them. But I think being able to show other projects, I have found as soon as I can show something in a magazine or another firm's website, look, they're doing it, lots of people are doing it, they're like, oh, okay. Because really, at first, what I'm getting is, you guys are the only people doing this. It's weird, and you're the only one. I've never heard of this before. And then I'm like, well, actually, there's a lot of us, and that's an eye opener. People just don't know.
Jacob, I was curious if you were getting any pushback from your concrete slab installer when you tell them that you want 3-inch slabs, or your foundation folks when you tell them you want a 6-inch wall, even though the engineering is there, it's something they haven't done probably. And how'd that go?
Yeah, haven't done the 6-inch wall yet, although we have definitely seen it in spec, and I've seen other specs where that's been installed. So I can't claim any direct experience from that. The 3-inch slab, I mean, really what the subs are most concerned around is being held liable for cracking. And if we have an engineer signing off on it and we're saying, nope, this is what we want, you're off the hook. If there's a crack, we take responsibility from that. That's pretty much what they need to hear and what they need to see, at least in our experiences on the slabs. I haven't tried the wall yet ourselves, so I couldn't say what direct experience on pushback of that move is, but I've seen it in projects, I've seen it in specs. Yeah, again, I think it's, a lot of residential projects don't have the soft costs available for a lot of custom engineering for a good reason, and it makes sense. But for those that can, or for those of us that are motivated to try and get that extra bit of carbon out of those assemblies, I really do think it's worthwhile.
So we're coming to the end of our time because we took, all 5 of us took a little longer chatting than we were hoping we would. We were overly ambitious with our 4-minute limit, but I'd love to just, if go around, and if there's a piece of advice that I know some of you said, as part of your presentation, shared some, if you were just getting started, or what you would advise people who are, earlier on in this journey, what would that be? Lillian, I'll start with you.
I think just following up on what Jacob was saying about pushback from subs, I get pushback from, say, my HVAC subs, because I'm very clear about how I want them to, test their installation. And I mean, they've said nobody does this. Nobody does it this way. And once I have some buy-in from them, it takes some conversation, and I'm like, don't worry, like, we'll compensate you for this extra time that you're going to take, or they don't believe that fewer heating units are going to do the job. But once they're on board, they're pretty proud of their work. And I think really focusing on all of our trade partners will help us move forward, because how many times have all of us heard, that's not how I do it.
Yeah, that's great advice. Matt, how about you?
I would say that the best piece of advice is go to Nessie, listen to everything that Chris and Jacob say, take copious notes, and then be thinking about it early on in design. Like in the schematic design phase, you can already be thinking about assemblies and be thinking about low carbon strategies. And that, it just makes it a little easier, and you're not fighting it along the way. It's already kind of baked in.
That's so true with everything. You gotta be thinking about it early. Chris, Jacob, what about you guys?
Yeah, I think there's a lot of value in setting goals, especially reasonable goals. I watched the crew at that Trent University job I showed briefly, a sort of very conventional GC company having to hit 0.6 air changes, passive house level air tightness, being really nervous. We went up and helped them a lot, but after the first blower door test, when they actually got it, their buy-in was huge. Like, yeah, we did it. And then same with the design team on the embodied carbon side, as we set this target and then looked at materials and then we hit it, and everyone was like, yeah, we got it. And that excitement, I think, carries on to the next project, that once people sort of you set something that's doable, but it's a push, but then when you can actually measure the result, when you actually hit that goal, there's a real up that sort of I think lives on into future projects and future work.
Yeah, I'm going to echo Chris on that one. Goal setting, I would say, would be my number one thing. It's so unlikely you're going to randomly stumble into a carbon storing building. But if you actually have some intention and set some goals around that happening, then it's a greater likelihood that you're actually going to get there. And the process of developing goals opens the door to everything. Do you need to learn more about accounting? Cool, that'll be part of your process. There's a communication of goals on the other side, and great, then there's an advocacy and communication aspect to it. There's looking at all the different opportunities within the design pipeline and the construction pipeline for how you can reach that goal. It just opens the door to like 100 different points of action and advocacy that are the most appropriate for you in your project. But it really starts with defining a goal, whether it's for your firm, for the project, for the process. That would be my number one.
Well, thank
All
you,
right, I'm
Jacob.
gonna jump in and say thank you again to all of you instigators and participants, for everyone spending the time on this really important topic in our industry. Again, the email address to the hub is in the chat if you're interested in joining that mailing list and getting engaged in the ongoing conversations we're having in this region and beyond. Please stay in touch, and we hope to see you all again very soon.
Thanks, everybody.
Thanks, everyone.
Thank you.